Hello guys, welcome back to the channel for a new Databricks video. Today's video could be about data validation in Databricks. Data validation is necessary and very important when you migrate data from point A to point B. You want to know that the final version of your data matches the source data. In our case, we have two datasets. The first dataset contains the test cases with the valid data, the data that we would expect to see at the end, and usually this is provided by the testers. And then we have a second dataset with the processed data, the data that we cleansed and transformed with our data pipelines. So these two datasets should match. If there are bad records, invalid records, we should get an email that some records were invalid and this dataset do not match with the source dataset. In the past, I used SQL scripts to make this comparison between the datasets, but using PySpark you can make it a lot more efficient and a lot more dynamic. The idea came from some good colleagues of mine that they developed a small testing framework for data validation. I thought this is pretty cool. I have to show this on the channel, of course the simplified version, but of course you can use it in your code. So let's get down to the nuts and bolts of this. Okay guys, we are here in our Databricks workspace. I have already prepared a Databricks notebook with code on how to compare the test data with the transformed data. Now, of course, the concept is very simple. We have test data. Let's say you have testers and those testers create test cases with valid data. The data that you expect to see, the final data and valid data. And then you have your data that you have transformed in your data pipelines, you have cleansed the data, you have processed the data, and these final data sets, you want to know that the data is actually valid. So what do? You compare these data sets. Now in earlier years, in previous years, we used SQL. Well, you can still use this method, of course, and then you compare those datasets column by column, and you create extra columns, flag columns, where you place your results. When you compare, for example, an ID column with another ID column from the different dataset, and then if it's not the same, then you know that this record is not valid. So you have these extra columns with the flags, and then you see which records are valid and which are not, and this is how you can actually test that the data is valid. Now in PySpark we have another cool way to do that, more automatic, and compare datasets way easier than using SQL, which is pretty cool. Although I love SQL, I think this is one of the cases that using PySpark you can achieve more things. In our example now, we have, let's say we have two test datasets. Let's say we have the first test data is here. Let's see the data, our test data. Let's say we have test case ID, and then we have these values here. You have ID, name, age, city, email, right? Okay, and as you can see, we have all those values here. Now, if let's say this is the valid data, and this is what your tester has as valid data, and now we have to compare this with the data that we produced and processed. So let's say you have a data pipeline, you process all the data, and then here you have the final output. Now the final output for these columns, for example, we have ID, name, age, and city, and email, right? Okay, we have the same columns, but what about our data quality, our data validity? And here, as you can see, for example, we have for Alice, we have Alice 1. So it's not the same with the original, with the valid data. Here it's Alice, and then we have Alice 1. So there is something wrong here, right? And here we have city San Francisco 1. It's not the same, it's not valid because it's not San Francisco, right? So how can we compare those two datasets? Again, the concept is pretty simple. We unpivot these data sets, and then using PySpark, we compare column by column, and we create a flag column where we say, you know, this is true, this is false, this is not valid, this record is valid or it's not valid, right? Okay, so what's the main PySpark function to unpivot the data? Well, it's the melt function. Here I found an article from this guy. It's pretty simple to understand, that's why I picked this article. And as you can see here, we have the melt function with the following basic syntax to convert a PySpark data frame from a wide format to a long format. Here we provide the ID columns, the value columns, and then the position and the points. Now here variable column name and variable column value. You will see in a little bit what those two are. So we have this data, right? We have these columns and we create a simple data frame with team, guard, forward, center. Now if you use the melt function, and as you can see, variable column name position and value column name points are the new column names. We have team because here as IDs we used team, and the values are the rest of the columns. And then we unpivot those columns here. And for variable column name and value column name, we use position and points, and as you can see, this is the final output. Now, back to our example. So we have, this is the first data set, and let's say we have a second data set, and let's see the second test data set. We have test case ID 2, and with the same data, exactly the same data, and let's say that our transform data this time is correct, so we don't have Alice 1 or San Francisco 1. So the transform data is exactly the same with the test data in test case ID 2, right? And now let's move to the code, now the key part here, right? So let's say the primary key is ID. You can pass a list of primary keys, and if you want to exclude the column from this whole thing, then just define it here in these columns to exclude list. It's not necessary, we just have it if in case you want it. Okay, let's move down to the code. Now in the main code, let's say we pass first the test data and transform data, which is the first data set. And for each table here, we use for loop and we execute this function. Now we pass the test table name and the transform table name. Now here is the execute function. What we do is pretty simple. We load the data, right? The test data, and we load the transform data. And here we use the melt function. Let's run the script up to this point here where we display the test data unpivoted, right? So let's run this, see what we get. So this is now the unpivoted data frame. You have ID, right? And then you have column name, test case ID, name, age, city, and the column values. And then ID here, etc., etc. So we have 4 columns, like test case ID, name, age, and city. This is the unpivoted test dataset, not the transform dataset. Now, here in this function, as you can see, what we do is actually for all the data frame columns, if it's not in the primary keys and it's not in the exclude columns, now this is the exclude column, the excluded column that we have here, which is email, and then we have columns to melt, and we print those columns. Now all those columns to melt are those columns here, test case ID 1, name, age, city, right? For the test data, and then we use select primary keys plus all these columns to melt, and here we cast it as string. We use call and then we cast it as string, and then we use the melt function, we pass the primary keys, the values, the columns to melt, the variable column name, and the value column name. Now here I use enumeration for the static values because they are static values. So if we go up here, we have an enumeration class called columns, and here we have test case ID, dataset name, key columns, key column values, column name value, value test, and transform, and is valid. So this would be some of the column names in the final result. And then what we do in the melt function, okay, we return the unpivoted data frame, and this is what we print, right? Okay, so pretty easy, right, to understand based on what the melt function does. And then let's uncomment this code here. We melt the transformed dataset, the dataset that we have already processed, and let's see the results of this melt function in the transformed dataset. And here we have the transformed dataset unpivoted. Again, we have ID 1, we have name, age, city, right? We don't have test case ID in the transformed datasets, right? We don't have test case ID. We have test case ID only in the test datasets. Okay, and now what we have to do is actually combine those two data frames here, so this one with this one, and then start comparing the values, right? Simple logic, the old logic that we used in the old days to compare the columns. Now I have already created and combined unpivoted data frames. Here we pass the data frames, and we have all the logic here. So we have the combined unpivoted data frames, and here we have the keys with the primary keys. That's why we copy the primary keys list that we have already here. Primary keys, we have a list, right? So we append those things, and we append the columns, column value name. And we are going to print, we will see the results here when we print that. Now, what we are going to do is actually, again, join those two data frames and then compare the columns one by one. So we have the test case dataset unpivoted. We provide an alias, and then we filter out the test case ID column, because actually we don't have test case ID in the transformed dataset. So we exclude that. Pretty simple, right? So we filter out the test case ID column from the test dataset. And then we use join, and we join with the transformed dataset. We provide an alias again based on the keys, right? And we perform a full outer join. And then we create new columns, and that could be column dataset name. So for example, dataset name here, we provide the transform table name here that we passed as a parameter. We split that just to get, the name of the dataset. Then we provide the key columns, and then we join. We use lit, so it's a string, and then we join the primary keys with this pipe here, and then we have column values. We use concat concat function, and we concatenate the primary keys using pipe again. And here we have from the test data, then we have the value from the test data set. Here we place the value of the test data set. Here we use column, the alias of the test data set that we defined here, right? That we defined here. And here we have the value of the test dataset column, and here we have the value of the transformed dataset. And then we do this very simple thing. We create a isValid column, a flag column. So here you see I have isValid would be a boolean, and here is a flag column, and then we say when the value of the test data is the same with the value of the transform data, then it's true. Or if they are both null, then it's true. Otherwise, it's false. And then we drop the columns that we don't want. And then let's display this combined data set, right? So let's display this one, and then we will continue with the rest. Let's see. Okay, this is the test data unpivoted that we checked before. This is the transform data unpivoted that we checked before, and now we have the combined data set. So here we have the column name, age, city, name, age, city, name, right? And then we have the dataset name. We have here data, right? And because the first dataset is actually, what was the name? Test data. So we split with underscore, and then we get the second, the suffix here, so which is data for this one, for the first dataset. And then we have the key columns we display, which is the key column here. We have the key column value, so here, for example, is 1. And then we have the column value test. So we have 3 columns, age, location, city, and name, right, for its ID. And here we have the column value test and the column value transform. So we compare now column by column. So we compare those 2 columns, column value test and column value transform. We compare those columns. This is 28, 28, this is true, so it's a valid record. This one is true as well, and then Alice and Alice 1 is not the same, so it's not valid, right? This is false. And this is false as well, San Francisco, right? It's not the same. All the other values, okay, and here the age, it's false again. So we have almost everything is true except all 3 or 4 cells that they are not. And we have flagged them as false. Okay, so this is the combined dataset, and this is pretty much the whole, the whole logic is here. This is the whole logic. Now, if you want to add the test case ID, so you can understand which is the test case ID for all those checks that you do, so use from the test data unpivoted, we filter the test case ID here, right? And then basically we just create the test case ID, and then here we concat the primary keys. So we pick the test case ID column, and then we use the concat primary keys that we used up here, right? And then we join this data set, so we rename the column value to test case ID, and then we drop the unnecessary columns, and then we combine this data frame with this data frame, right? So let's print the test case data set to understand what this data frame is, which is pretty simple, right? And then we join those two. We can use inner or left outer join, and then we select the columns that we want to display, right? And here we display the final results as well. Okay, so let me comment this out. So let's comment this, and let's run the code and see the test case dataset and the final dataset. Okay, so we have the test data and pivoted dataset. We have the transformed data and pivoted dataset, and we have the combined dataset that we checked, and then we have the test case dataset, which is actually the ID, test case ID, and the key column values, and the final dataset, which has the test case ID, the dataset name, the key columns, key column values, and all these things that we checked before. Okay, so let's say that you have two datasets to check, right? So you have test data 2, another test case, and you have the transform data 2, which is another transformed final data frame that you have processed. Now it's pretty easy with a for loop to make it more dynamic and pass all those data sets that you want to check. And here we write the results in a results underscore transform table name in order to see the final results. So we can have the results, those the final data set that we checked here, so this final data set here, we can store it, you know, as a table, and then we can always check what happened and what went wrong, and it's easier to check our data. Now let's run this. Let me use this, uncomment this, and here we save as table. I think we are good to go. Now we are going to do the same thing for two data sets. One would have invalid records and one would also only have valid records, because the second data set has exactly the same values with the test data set, right? Okay, let's see. It is running. Give it a second. Okay. Now this is the first data set, right? Now we have the second data set, which is the same exactly, but the transformed data set is exactly the same with the test data set. So if we go into the combined data set, as you can see, everything is valid. And we have the test case data set, test case ID 2, right? And that's the final data set here. Now I think it's easier to see it here. This is the final result for test dataset 1, test case ID 1. As you can see, we have false values here. And then for dataset 2, everything is perfect. Everything is valid, right? Now, one thing you can do here, so you have those tables, you can check manually, you know, which records are valid and which are not, and you can override the data so you don't, take a lot of space. But you can also create workflows, and actually, let me show you the Databricks Notebooks here. So for the first dataset, for each dataset, you can check if there is a record with false, which is not valid. Actually, we count the records that they are not valid, and if it's greater than 0, then we can raise an exception, and I will tell you why we can do that. And the same for dataset 2, exactly the same thing. We check if there is invalid record, if the count is greater than 0, then we raise an exception, otherwise we print all is valid. And then you can create a workflow here, and you have two tasks, right, or multiple tasks depending on how many datasets you check. So the first checks the first dataset and it points to the first notebook that I showed you. And then here we have, if you click on the notifications, if you click on edit notifications, you can provide an email address, and in case of failure or success, it will send you an email, right? Which is pretty nifty because you can schedule the workflow to run, you know, after you run your test pipeline, and then you get the results in your email address. And the same here, again, in the notifications, you add your email address. Now, if you run this now, let's run this, and we should expect two emails. One email that, you know, the first data set has invalid records, and the second data set, everything is valid. Okay, here we are. As you can see, the first data set failed because we raised an exception, and when we raise an exception, the task fails, right? And then we can send an email notification, and if everything is alright, then it sends an email notification on success for dataset 2, for example, right? All is valid, and we send an email notification. Now if we go into our Gmail account, the second dataset, check dataset 2, status success, duration, etc. So this dataset is fine, but the first dataset failed. That means check dataset 1 failed. That means that they are invalid records, and now you can go into your Databricks workspace, and check the data manually and check your, which columns are not valid and which are, and etc. So pretty much this is it. This is the main logic. We use the melt function to unpivot the datasets, and then we combine those unpivoted datasets and we compare column by column the values. It's a pretty nifty way to do it with PySpark. This is it for today, guys. I hope you enjoyed the video and you learned something new and that you benefited from this video. This is a new concept also for me, because I am very, I like SQL, and I used SQL script in the past to test the validity of the data, but there are times that PySpark is much more efficient and effective than SQL, especially when you want to automate things and compare many test cases simultaneously, etc. You can also send email notifications. I'm going to upload this code on GitHub so you can take a look and play around. Thank you for watching, guys. If you like the video, please subscribe to the channel, click the like button, leave a comment, and I will see you in the next one. Thank you.